Alright ladies, today we're going to cover the last part of 2.1, and that is histograms. Histograms are very similar to bar graphs that we've already covered, with a few specific differences. A histogram is for quantitative data, like graphs that we talked about last time. The bar graphs, on the other hand, are for categorical data. So if I had something along the lines of countries of manufacture, for instance, USA, India, UK, New Zealand, Japan, I would use a bar graph because I'm talking about categories, whereas if I'm talking about age ranges or something like that, I would use a histogram. So that's the mathematical difference. The visual difference is that a bar graph will have gaps in between the bars, categories across the x-axis and frequencies on the y-axis, while the histogram will have numbers across the x-axis, frequencies on the y-axis, and no gaps in between the bars. So a lot of times histograms are the more common way to display information. Compare it to a dot plot or a stem plot, most often used in media and things like that. And here's an example that should be on your handout. So you have the number of hours of TV watching in a particular weekend, and the proportion or the percent of people who answered in each category, ranging anywhere from no TV in the weekend to 13 hours of TV over the weekend. So what is the most common number of hours attached of TV watched? So if I had the highest bar, you would have called that in grade school, and that is still true, the mode. So it has a mode of 2 hours, the most common amount of TV watched over the weekend or in this time span would be 2 hours. Approximately what percent of the survey watched 6 hours of TV? Find the 6-hour bar, see where it matched up on the y-axis, and found that that would be about 5%. And then approximately what percent of the survey watched fewer than 2 hours of TV? So that would be people who watched one, people that watched 1, and people that watched 0. Add those two together. So we have maybe about 22% plus another 3%. So we would say our answer there would be about 25% of the people surveyed. Now, just like with dot plots and stem plots, there are 3 things we're going to look at when we describe a histogram or when we compare histograms, and that is shape, center, and spread. I actually put center and spread first here because those two have not changed from stem plots. We have the center would be at the midpoint or median value. Your range or your max minus min will still describe your spread, and your shape, we're still talking about how many peaks and is there symmetry. We're going to be a little more specific today in terms of the vocabulary we use. So previously we'd worked mainly with things that were symmetric or were not symmetric. Within the symmetric range, there's actually, and I'm going to scroll back up in just a minute, but there's 3 different categories of symmetric histograms. So you have unimodal symmetric curves, which means it has one peak, and that peak is in the middle. That's the symmetry part. You have uniform, in which all the bars are exactly or approximately the same height. Okay, so you still have that symmetry around the center. The center of 5 in this case, the left and right side are mirror images of one another. And then you also have the possibility of a bimodal symmetry, meaning where you have the 2 peaks, but they're still symmetric around the center. Now, if you don't have symmetry, there are 2 other possibilities, and that is that your distribution could be skewed. And skewed still has 1 peak, but the peak is off to the side instead of being in the center. And typically, this is going to seem counterintuitive, but we describe these based on where the tail of the distribution is, not where the majority of the data is. So if the majority of the data is, like in this case, on the left-hand side in the lower range for the number of hours of TV, we actually say that that's skewed right, because the The values on the right are what's making it, are the unusual values, the ones that are making it not symmetric. Likewise, over here, if I'm talking about the milligrams of sodium, you have the majority of the data over in this range, with the few possibly outlier data points over here on the left. So you would say that that one would be skewed to the left. Okay, and you can see that there's a wide range. This one's very obviously skewed. This one's a little harder to see. So a little bit of gray area here in terms of how you describe the shape of it. But just wanted to get you started to talk about talk in terms of those vocabulary words, because we'll be using them throughout the rest of the year. So if you would like, you can pause the video now for a moment, jot down some of the visuals for the different shapes so that you have those to use from here on out. Now we're going to pause this video in just a minute and go into a little bit of an activity, and there are directions on your handout for what you need to do. The link up above you can either type into your browser of your choice, or you can go to SchoolFusion if you've already had that up from obtaining the video, and click under the Chapter 2 links. And then there's one called histogram. If you click on that, it'll take you directly to this. What I'm going to have you do on here is mainly look at the different data sets. So you have a little drop-down arrow right here to allow you to choose different data sets. The ones it defaults to, I believe, is SAT math scores. And then based on a data set of the SAT math scores, and then later of one of your choice, you're going to see how changing the scale affects the shape of the graph. So you're going to focus on this slider here that will change how wide the bars are, so how the data are grouped. And you're going to change this right here, which is the maximum value of the y-axis. That'll affect how tall the bars can get. And in either case, just make note of how that changes the shape of the graph, and if that's consistent for several different data sets. There are also some questions, I believe, about the general shapes of several of the distributions that hopefully you can use the information I gave you in the previous slide to fill out. So go ahead if you have not already and pause the video here. Go on to SchoolFusion and use the SchoolFusion in your handout to complete this activity, and then come back and pick up the video where we left off. Do a little bit more by hand besides just taking notes before we go into actually making the graphs with technology. So in this case we have some data, the number of red Skittles in small fun-sized bags, and you have a bunch of single-digit values that I can tell would be easily split up just by the counts. So I'm going to have the count of red Skittles and how frequently that happened out of my survey of bags of fun-sized Skittles. And so I have anywhere from 1 to 5. The 1 happened twice. Cross them off as I go. The 2 happened 5 times, and so on. So keep going in that manner. I'm going to pause here, fill it in, and catch up to you. Okay, so we are now have total or counted our how frequently each value of the red Skittles popped up. Notice I have changed my value in the table. I didn't want that to be confusing because our book uses the word count and frequency interchangeably. So I changed the left side of my chart just to read the number of red Skittles, and then the frequency or the count here. So I had twice there was only 1 red Skittle, 5 times there were 2 red Skittles, and so on. So on my graph over here, my frequency or my count is going to be on the y-axis, goes up to 5, so 1, 2, 3, 4, 5. Once again, that's how many times it happened out of my samples of red Skittles. And then on the x-axis, this is where I'm going to put my number of red Skittles. Okay, that also went between 1 and 5. And when I draw my bars this time, since it is a histogram, I'm going to make sure my bars touch and that they are centered over the value. So 1 red Skittle happened twice, 2 red Skittles happened 5 times, 3 red Skittles happened 3 times, and then 4 and the 5 both just happened twice. And then, like before, you can, if you like, label the tops of your bars if you like that look. Otherwise, as long as it is neat and you can read it from the y-axis, it is not needed. Okay, I would still add a title though, so number of red Skittles or red Skittles in fun-size bags, just because it might be different in other sizes. Okay. Next, we have scores on an algebra test. Now notice this is not quite as nice of a distribution. I'm not going to want to make a bar for each individual score. For instance, 61, 62, 63, because I have to go all the way up to 95 and as low as 62. So what we're going to do in this case is group them. So I notice I have 60s, 70s, 80s, and 90s. So in my chart, I'm going to give a range of grades instead of just a single grade. So for instance, 60 all the way up to 69, 70 to 79, 80 to 89, 90 to 99, and then when I'm finding my count or my frequency, just find how many grades fit into each of those categories. So once again, I'm going to pause here, give you a chance to total those up, and I'm going to do that as well, and then I'll catch up to you. Okay, so I have found 4, 5, 2, and 2 respectively for the counts of my scores of my algebra test. And I have gone ahead and drawn in my x and y axes. So my x-axis is the grades. Notice I went ahead and just put kind of every 10th number, 60, 70, 80, 90, 100. So I'm going to, in this case, draw the bars in between the values, since my grades that were in the 60s would be anything from 60 all the way up to 70, because you can't, I'm going to assume there's not a 69.5 possible, for instance. And then I'm going to go ahead and fill in my y-axis, just going by ones since it only goes up to 5. So there were 4 scores between 60 and 70, 5 in 70 and 80, 2 scores in the 80s, and 2 scores in the 90s. And that tells me good visual for illustrating the grades that were achieved on the test. Might need to go back and study that unit just because there were so many grades that were down here below where you would want them to be. This last slide I'm going to put on here before stopping this video and giving you a chance to work with some practice problems is the instructions on how to do a histogram in the calculator. So we're going to go into the Stat button and Enter and Edit. This is the same place we'll use a lot this year, so I would hopefully put this in your memory, save it for later. If you go Stat, Enter, and Edit, it will look like this. So go into the Stat, Enter for Edit, and there is your list. Now I have information from something else earlier today. Go up and hit Clear, Enter, and that'll get rid of my data without getting rid of my L1, and then I can put the numbers into L1, Um,